It's pretty dark. Igor? Ivan? Oh, isn't it Ivan?
De most Ács, ez ugyanaz a link, nem? Hát én is. Azt mondom, hogy mindenki YouTube-ban legyen, aki bejön. Jó.
Hello over there. So, can you hear me, guys? Presenters? Jürgen, okay? Gregory, okay? Aaron? Okay, I'm waiting to Aaron to say hello to us. Aaron, please unmute yourself. So guys, we are online now with the picture, hopefully. So you say you can't unmute. I will try to help you. Actually, principally, Aaron, can you give us a speech now if we make your micro working? Please show me because I cannot see you. Cannot hear you, actually. Aaron? Oh, you can show your presentation. Good.
You guys hear me now? Everyone hear me? No?
Oh, Aaron, thank you.
Yep, back.
So, guys, unfortunately, we have 30 minutes. We are late, 30 minutes or more, even more, okay? I want to say hello to our guests and the promises at Logmein company, who is our host. I don't know if we have any YouTube viewer because we had to change our YouTube link. We announced the link for on a lot of channels, and now the link has changed. Actually, that was the thing I wanted to start with. That our meetup today is an experimental one. So it's the first time we do such an online meeting, and it was a single click to wrong place that made it with us. So we had to change the broadcast link, and we had to change the Hangout link also. But you can see our presenters online. That means that that we can make your meetup, and only those suffer who wants to see us or plan to see us at the old link. Sorry, I forgot to be in the picture. Well, if anyone is online with us on YouTube, I have to explain our situation. I mean, the originally planned situation, that we have a couple of special guests here at Logmein in Budapest, and probably we have someone watching us live on YouTube. The probability is just low that anyone could change to the new YouTube link, but and sorry for the delay. Partly delay was just because of that we had to announce, try to announce the new YouTube link in order to let us as YouTube visitors to switch to it. So anyway, that was the start of the experiment. We failed with the start, but we can continue. And the first presentation was should have been made by Attila, but Attila will deliver his talk later, and we will ask Aaron to start. But before Aaron, you start, I wanted to explain that this hangout or this meetup is a joint effort not only of OWASP Hungary and Longmean, but also we are helped by other chapters of the region. So if online or probably recorded, or colleagues from Romania, from OWASP chapter Romania, from OWASP chapter Cluj, or as it generally known in Hungary, Kolozsvár, watch us online or recorded, we say hello to you, and probably we have some, we will have some listeners from the Poland chapter and Austria chapter, probably from the Russian chapter, and I hope very much that someone from Ukraine could can also see or meet up later. Well, if someone is online or on our YouTube broadcast, then they can comment on the event. So if we have online questions, probably, then we will ask our presenters to answer the online questions too. We will try to maintain this online event, but absolutely we will have some other glitches. Please forgive us for the glitches. So okay, our topic is security of the Internet of Things, and I think that today we will hear a simple idea that security is incompatible with things connected to Internet, and I just tried to invite two our Hungarian colleagues to this event, famous Hungarian hackers or specialists in our area, and they said that there is no such thing as security when we are talking about Internet of Things or things connected to the Internet. And yes, of course, it's not a new thing. The problem with embedded systems, the security of the embedded system, is old, and it always was a horror. What embedded system, the security and the embedded systems, the vulnerabilities of the embedded systems. Now we have this trendy word of Internet of Things, and now we have these things connected to the Internet. So, okay, we have an old problem in a new circumstances. I don't want to speak more. I'm not a speaker today. So, Aaron, if you can start your presentation, please.
Will do. Give me 1 second. All right, so does everything look okay? I can't see anybody's screen, so I can only see mine. Everybody hear me? Let me go back real quick just so I can see.
Yes, we hear you and we can see your presentation.
Okay, awesome, sounds good. Okay, I'll get started. So what I'm going to talk about is generally just securing the IoT, since Timur basically said there's no security in in IoT and embedded devices, there's a lot to do with it and a lot of reasons why. I'm going to get started talking about a lot of different things that go wrong and a lot of things that we can fix in embedded systems. So a little bit about me. I'm in the Los Angeles area. I'm a senior pen tester for Balkan, so my job is to secure the Internet of Things per se. I'm also another chapter leader. I do Cloud Security Alliance in HTCIA, which is with the private and public sector over here in the U.S., mostly like Secret Service, FBI. There's my Twitter handle there if you'd like to get a hold of me. So we're going to talk about just a little, go over the light basics of IoT, going into the protocols and the supply chain of making these devices, and how many devices are out there, and then what the real issues are for security. And I'm going to talk about the resolutions, things that we can deploy and fix and make the devices more secure. Here are the basics here. So, according to Gartner, the Internet of Things is just a network of physical objects that contain embedded technology to communicate and sense or interact with the internal states or the external environment. Like the cloud, you have an embedded device from your local network contacting the cloud and coming back into your local network to control your devices. You have things such as wearables, you have security cameras, you have smoke alarms, you have thermostats for all smart homes, but then you have the smart cars, which have internet enabled. I don't know if you've seen the commercials, if they're over there on your side of the world, but they're giving cars 6 months to a year free Wi-Fi, as well as other applications installed in their car. You also have wireless sensors and things for your body as well that have wireless control for electromagnetic pulses through your back. You have smart buildings, smart cities, just completely wired from usually Zigbee protocols, which we'll get into a bit, to communicate with other devices in the city as well. So let's get started with the hardware. Whatever it is, whether it's smart city, wearable, smart home, you'll start with some type of hardware device, typically in a smaller form factor. These are just easy, things you can buy off the shelf, like Arduinos and Raspberry Pis, Raspberry Pi 2s, and Pan Steps. But the thing to keep in mind is that these devices or these hardware platforms are really, really cheap. Like this Pan Step is like $18 US, while the Arduino and Raspberry Pi 2 are about $40 US, which is not a lot of money to start creating your own project. You can get creative with it by adding on operating systems and frameworks. There's OpenWRT AllJoyn that is making an attempt to create a standard for all IoT devices to communicate in one type of transport communication way. You have Riot OS and you have HomeKit, which is proprietary, that requires a secure element to store information on the iOS devices specifically. There's no plans to go to Android, so there's a little bit of issues there, but it has, it's more like a hub of, let's say, home automation. So where these devices also communicate, internally within the network, it has to call out to their platform, which will be the cloud, that has some sort of API that connects these devices for control. So you can control it through your mobile app, which is typically what it is, mobile app or some sort of control panel that has an application to where it calls out to the cloud, keeps a connection open, and calls back down whenever it would like to, basically traversing your local network. So you have platforms like everything that connects your business apps, your consumer, your products, things in the market, QR codes and things that will eventually be deployed. So you have just these platforms. You have everything. You have Microsoft Azure's platform as well, which all have different protocols. There's nothing that standardizes with protocols though. So you have Zigbee, Z-Wave, Lutron, Bluetooth, LE, which is low energy, MQTT, and you have things like REST and SOAP, and GSM, which it's kind of a Wild West because everybody basically makes their own standard for whatever they see fit, and they have, they're not really playing nice with other devices as far as with the, I don't know, I would say layer 7 application layer of controlling these devices, which makes it hard for other people to integrate. They may have their own SDK, but it'll be not very scalable. So you have things like hubs that will kind of glue it all together. So you have the Wink Hub, Insteon, and SmartThings. For example, the Wink Hub has peripherals that can control Z-Wave devices, Lutron, Bluetooth LE, Wi-Fi, and Zigbee. A ton of options there that kind of controls everything from one app. But it's kind of a shame that it takes devices like a hub to control these all these other devices in the ecosystem. And Wink and Insteon and SmartThings are kind of for home automation right now, smart homes. But you'll see them later on as they get deployed into businesses. Maybe beefier hardware and bigger type of appliances. But just to keep kind of control of the different protocols, you have these things called hubs. So there's according to Gartner, 4.9 billion devices that will be connected in 2015. Now that's a lot of devices. To think that they all have different protocols, different hardware, different chipsets, different functionalities, different apps. They can be on iOS, they can be on Android, Kindle, whatever it may be. 4.9 billion devices is a lot. And to think, how can we keep those secure with so many different variables in play? So I'm going to get down to the details of a little bit of the details on how these hardware devices kind of get started with, the board support packages, the BSPs, people like Marvell, Broadcom. You've probably seen these in your PCs or your Macs, your Linux. You see them mostly as Wi-Fi chip vendors, but they do more than just Wi-Fi. They're the people who create the drivers to connect to, the SDKs that will talk to the motherboard. So that's the key thing to take away from this, is that they create the drivers that, you can talk to. A lot of the times, people say that, hey, I get a binary blob, but it's these guys who will distribute that binary blob for their drivers. Now, you have devices that, routers that may be open source that these companies might be able to open source their drivers for whatever the purpose is. Security folks generally want to be able to patch their own or customize their own kind of drivers. So you have ODMs that basically take the SDKs that the BSPs post or give to them, where they can design and basically create a minimal stack, a software stack with a basic user interface, a web server, or something like that that's usually rebranded to, for a bigger company, another company, or smaller companies that distribute it out. And they provide their own SDKs as well, and APIs that communicate to their software stack that has been designed. There's many of these ODMs, typically like in China, and there's a lot of them. I mean, I'm on design calls over here at Balkan, where I'm basically vetting out these companies that have no idea how to secure their ODM stack and their API, or even scalability for the API. So I've seen a lot of them. I've talked to a lot of them. And we'll get into a little bit of the positions later of what ODMs consist of. So with building these devices, like I said, you have to have some sort of platform. So you have, like cloud service provider, Amazon, Microsoft, Google's, and ODMs even have their own. So I couldn't create my own company if I want to, and some do. That not only create the software stack, but also create a Amazon account that also can host your app's infrastructure and what your hardware talks to. So I mean, and these kind of clouds pop up. I mean, they'll call it their own, but it's usually in the back end, either Google, Microsoft, or Amazon, typically from what I've seen. Then you have people like Balkan, who is an ODM, who actually offers warranty and support and licensing of the product, where we deploy it and we kind of put our name on the line. At the ODMs don't you know, they don't really have their skin in the game, as you can say. They're not worried about certain issues or scalability issues, because they're just creating these software stacks that they're just going to give to an OEM to build their own software stack. So, you know, security in that, I'm not too sure if the developers even care. But here's the supply chain of IoT and some of these devices here. You have the BSP, the ODM, the CSP, which is the cloud provider, which can also be combined with the ODM, and then it goes off to the ODM, who then deploys it massively to the whole world. So in each of these, likely to outsource development to multiple other teams. You might have the BSP that has 3 dev teams, one for the kernel, one for service, whatever it is, one for the hardware architecture. Same thing for the ODM, one for the web server, the UX, the user experience, the user interface. And the cloud service provider, I mean, that's, you know, they mostly have pretty good guys for security if they're using, you know, the Amazons, the Google, and the Microsoft. And then OEM, I mean, I'm not too sure on how many other companies like Belkin have security teams, but it's not even just Belkin. I mean, you have other companies that also create these devices and deploy them throughout. So, and keep in mind that these hardware pieces, whether it's the chips, the peripherals, you know, you have a Zigbee interface or a Z-Wave interface that also tacks on to the board, the main PCB board. They all come from different places, and these boards are all soldered together from different places. So when trying to keep that secure, I'm not sure it's too feasible. They're just trying to get it out the door, and they have hundreds, millions, thousands, billions, whatever it is, devices that they need to get out. So the primary roles of these typical like ODMs would be sales, project managers, or program managers and engineers. And their typical responsibilities, you know, sales to get, basically to get the business and outreach to companies that may be interested, calling back, you know, people who are interested in creating their own business, entrepreneurship, creating relationships with big companies, because that's a lot to do with it as well when creating chips and different chipset vendors. You know, and PMs are just worried about prioritizing objectives and seeing, you know, what should get done before this project. And then it's usually project specific to an engineer team, like I was talking about with UI and UX. They have different focuses, and you know, it's their concern is just to get the product out, like any other software development type of company. With engineers who write code, and you know, either it may be big or maybe small or maybe outsourced to 3 different other contractors, but they all have different workflows, and they all may have different training or lack thereof. But who's looking at security? From the companies I've talked to and that I've researched, and I've tried to, you know, do some LinkedIn searches as well. You know, there's so much to worry about with even just embedded security. Going down to the BSP level, you know, you have common attacks with the TCP layer and tool chains that get installed from the BCP or the ODM. Maybe the BCP only creates the drivers and the ODM creates their stack on top of it. It kind of varies in that end. You have UART, which is serial connections and JTAG interfaces, which are also common. You know, and less common would be like Flash and GSM, GPS. Kernel type of vulnerabilities. You know, so then you have these people who also have to worry about Android app security, or they should be worrying about as far as ODMs, OEMs, or just the whole supply chain. Typically, an Android app can be, the ODM can create this as well if the OEM you know, doesn't require that they have to. Usually, you know, for these IoT companies, they make it so easy to create this rapid development of these devices so they can get it out to market. So with Android, I mean, we have typical, you know, web view security and, you know, permissions with Android manifest and memory for buffer overflows, because on the device, you know, it's still relevant, and creating sessions over SSL so you can have that confidentiality to where you're talking to the platform, the cloud, and coming back down to your local network. You have iPhone security as well. You know, depending on what iOS SDK, there might be some vulnerabilities. There might be, with HomeKit, maybe they might not know how to securely input something into their secure element, or they might duplicate it out to the log or something, just so they can have some debugging enabled. And data protection APIs, web application security. There's just so much that they have to worry about. But who's worrying about it? There's no one specific. We're leaving all the responsibility on the developers, who may not have any experience in that. So they're not experts, and that's why we kind of think of embedded devices and IoT as kind of like a fail, because how are we supposed to keep track and know who's responsible for all of this type of security with web app, mobile, and hardware and embedded? Let's start with some security downfalls. I mean, I found this really good article here that says that's kind of what I'm trying to explain, and kind of my point of the talk is, it says, because computers go through so many hands before they're delivered to you, there's a serious concern that anyone could backdoor the computer without your knowledge. Depending on which code it's kind of written in, I mean, it could be in something as, system language code, HDL, that you will never hear or see of a backdoor unless it's somehow communicating unencrypted or not during startup. You have things like, people have seen this with router vendors, with backdoors using user agents and secret codes that open up a telnet session. You have debugging scripts that give you information disclosure, and those are typically from the ODM. They're not typically from the OEM, because it's used and needed for manufacturing purposes that off the line meaning manufacturing, they use it to test. For whatever purpose, they need some of these debugging scripts, from what I've seen and what I've read. And then you also always see and know that UART pins are always exposed. Usually it's either UART or JTAG, but UART pins can be, silkscreened, epoxied, or something like that to make it a little bit more difficult, or kind of sway the researcher to kind of look otherwise. But even when UART pins are exposed, they're typically not authenticated with a complex password. Usually it's pretty simple. There are plenty of DEF CON talks about it. They crack them within, an hour or so. But it's kind of scary because you see private keys on devices, where vendors and developers, they kind of think, hey, no one's going to look in the binary. It's in the binary. It's safe. It's not like mobile devices where you have a sandbox and no other devices can enter that sandbox. These devices are in people's homes. They're going to crack them open. You don't know exactly what they're going to look into. As far as they're concerned, as their device, they have full control over what's inside of that device. And they have every right to. I would, and I do. So here's some ideas that we can secure, the embedded world. You can restrict shell completely from any external type of interface. Like I was talking about with epoxy and silk screens, you can have very long passwords. If you're going to leave the UART connection exposed, the pins exposed, you can update kernel packages, update kernel and the packages, because you have other libraries involved as well, whether it's UPnP, SMB, any DHCP packages, and you also have to keep these updated with secure updates, whether it's pinning, GPG signing, some sort of cryptographic signing, as well as the use of, getting down to embedded with secure C functions. When you have leaving your buffer, or you use gets or string copy or anything like that, there's a whole list that we can go through. But these devices are like mobile devices where buffer overflows and things like that and command injections are very, very real. And they're mostly because these kernels are old, and the developers who are C developers don't know what is illegal as far as banned functions are concerned with C. So we all have to verify and test before these devices are out in production. So I have a couple funny little infographics here that I found with regards to C functions. Let's just look at that for a little bit. All right. So now you have, because of the impact that these devices may have with, 4.9 billion just within a year, People like FTC or the EU Commission are starting to take notice. Like, hey, this is going to be a pretty big deal, and it's not going to go anywhere. It's not just a movement. It's not just a word. It's kind of the same way mobile computing and cloud computing. Everybody gets stuck in the semantics, but now we all know mobile's mobile and cloud's cloud. It's not such a big deal anymore. It's reality. So FTC and the EU Commission are starting to publish documents like implement security by design and privacy by design. So here's here's a quote from FTC. They've been posting, say, like 4 articles a year and workshops as well. One of them stating, implement security by design rather than grafting security on as an afterthought. Build it into your products or services at the outset of your planning process, which is key, because if you can't just bolt on security. Security is not a product; it is a process. So I mean, they're now starting to categorize IoT devices, whether they categorize routers as IoT devices. They categorize, because now, just like how we have here at Linksys, we have our routers controlled via mobile apps now. We can set port forwarding now for when we're away, kick people off our network, whatever it is. You have cameras, and you have smart homes for categorization of IoT devices. So it's kind of going to everywhere with wearables and things like that. And since these companies, IoT companies, they don't really have like a PCI or any type of like bank regulations or anything like that. This is the biggest protection to consumers as far as smart home is concerned. There's a lot of standards organizations that are thinking and worrying about the enterprise deployment of these IoT devices. One of which I'm a part of, which would be with Cloud Security Alliance. It's called IoT for Early Adopters, which we are trying to create a standard for deployment, secure deployment, and device management and such. So if anybody is interested, please feel free to message me. But with all these regulatory posts or articles or press releases, from the FTC or EU Commission, there's something missing that I don't see. They're talking about implanting security by design and privacy with software development, but again, these developers, PM, salespeople are not security professionals. So what's missing is the supply chain of these devices that I kind of went through earlier. How can we make this more secure? How can we make this supply chain more secure? I would say liability to the ODMs that, hey, there's not going to be any backdoors. There's not going to be any debugging scripts enabled by the time we deploy, and have some legal repercussions, with these partners that you're making deals with, because the OEM is taking all of the PR hit, the public relations hit, everything that's posted online. You have post after post. You have bigger PR firms. You have bigger news entities that are posting things about security now. So it's pretty important that these type of service agreements should be made with repercussions to that agreement as well. Community projects as well. So to get the awareness going with IoT, get involved with the project and kind of help out, get started early on. That way we're not, as security professionals or developers or PMs, working backwards to build in security. So as the FTC was saying, get involved in the planning process, which is into the software development lifecycle. Having just a security thought or a mind, a person who's there to give that input, is key. Here at Balkan, this is what we're doing. We have planning sessions with our project management and our program managers on how we should deploy this camera or whatever it is. We also, I think we need a common certification similar to Wi-Fi and Zigbee, to have that kind of sticker on there that says, hey, these conform to these standards, and then or collaborate with these groups. I'm involved with meeting groups, working groups with Wi-Fi Alliance and Zigbee Alliance, but these type of conversations aren't really ongoing for common certification where we can add security into it. So is it realistic given the supply chain? Not too sure, just because of the so many hands and so many teams involved. You would think just for a simple app and a simple device, you'd have like maybe a handful teams involved for engineering team, but in reality, there's way more. It's broken down into functionality. So you have a setup team or a functionality team, whatever it is, or a certain new feature, a hot fix, or anything like that. But ways to help, aside from getting community projects, is being on the offensive side and breaking these devices with Build It Securely and Bug Crowd. Build It Securely has a number of researchers readily available to test these devices before they go out to production. So this gives you a way to secure the consumers or whoever is deploying this device, whether it's for the enterprise or consumers. So get involved with Build It Securely. Mark's a great guy, and so is Zach. Bug Crowd also has, they have Wink right now. We're also we might be getting involved with Bug Crowd and give, the hardware devices for security researchers to test. We're all in this to keep everyone more secure. We don't, there's nothing to hide as far as our organization is concerned. Like I said, we have things like OWASP, where I have, some defense strategies that developers, can reference. For embedded, for IoT, they have the IoT Top 10. I'm just creating the embedded security project within the week. So feel free, if you need any of these resources, I'll be happy to help anybody out. That'll be it. Thank you.
Hello?
Yes, sir.
So we have not got online questions, but probably we have questions from our physically appeared visitors.
Yeah, if anybody has any questions, feel free.
So no questions? Aaron, sorry, Budapesters are shy, so we will probably turn to the questions. Oh.
We have one with Gregory here.
Yeah, okay.
So what Gregory is asking is, what does privacy by design mean? And this is pushed not only by FTC here in the US, but also by the EU Commission. Privacy by design, their idea of privacy by design is basically collect as little information as possible from these devices and not make them personal identifiable information. So basically tied to an individual. So whenever we're planning to, for devices to be created in the planning stages, you don't have to get personal information with regards to the individual, but more so usage of the device. But again, keep it at the minimal, at the smallest amount of data that you can possibly grab is what their idea for privacy by design. Does that answer your question, Gregory? Thank you. Welcome.
Okay. Now we can see the features of our facility, which are good. Okay, Aaron, thank you very much. You were the key speaker. Gregory, you wanted to ask us another question? Yes. Okay. Aaron.
Go ahead, Gregory.
Gregory, do you want us to make you online, probably?
Yes.
Okay. Can you unmute yourself? Was it? Oh. Okay. You are muted.
Go on. Yeah. Go on.
Hi. I have a question about supply chain security provided by the supply chain. I mean, we have experience here in Europe issues with beef meat, where the supply chain was supposed to be under control, and we had health sanity issues from people that all the way were at some point were cheating about the real origin of the meat. So in a worldwide distribution of things manufactured by in different places on the planet, what do you think? Do you have any pointers or ideas how to accomplish supply chain security on the whole supply chain?
So security in the world supply chain is that what you're asking? Or basically how to start the process.
Gregory, please mute yourself. Okay.
Can you hear me? Okay.
So it's okay now.
Okay, awesome. Well, it's hard because everybody is going for these cheap hardware devices, these cheaper chipsets, whatever they need for the functionality of their device. If it has the peripherals for Zigbee, Z-Wave, whatever it is. Now, it's mostly on the hardware level and ODM. So you have startups who look for the cheaper ODM that will create the software stack because they just have an idea. For example, you have Wink, who lets individuals or inventors submit their idea, and they'll kind of create that idea for you and give you the credit. But as far as the supply chain for, from the beginning of getting the hardware device over to assembling it and then, putting your software stack on it, which is typically in countries like, China, unless they're tested or held liable for their jobs and the security of that device and making sure that the code on that device does not leave anything that will give some sort of disclosure to the device and compromise the integrity and confidentiality of the device. It's going to be hard. It's not to say that it might not happen, but it'll be hard. I mean, I think this liability is the key to holding the supply chain more liable to security issues. Because right now they don't care. It's just I'm going to create the product and get it out, and you have to worry about the security of it. Or they might not even think about the security. They're just worried about getting their hardware assembled, getting their software stack on it, and passing it over to the next person or the next company, whoever it may be. So having some sort of agreement and liability.
Okay. Gregory is satisfied?
Thanks, Gregory.
Thank you, Gregory, for the question. And Aaron, thank you very much for the presentation, the answers. Still no questions in the...
Not a problem. Thanks, guys.
Aaron?
Yes.
Okay. Then we are finished with your presentation and the questions.
Thanks, Timur. Thanks, everybody.
Thanks, Aaron. Please stay with us if you can. Ivan, are you over there? Ivan, if you can unmute yourself, or if
Am
not.
I the next speaker?
Oh, nice.
Okay. Ivan, hello.
Hi. Listen to me, right?
Right. So probably we can go on with you, Attila. Just a moment, Ivan. Attila wants to say a few words.
Yeah,
Sziasztok, először is üdvözlök mindenkit itt a Logminnél. Még egyszer elnézést kérünk a technikai problémák miatt, de ellensúlyozni tudjuk ezt indokolatlan mennyiségű pogácsával és hűtővel a sörben. Sörrel a hűtőben! Úgyhogy nyugodtan szolgáljátok ki magatokat, akár a speech közben is. Köszönjük szépen!
Sorry guys, it was about about the sandwiches here. Okay, but before sandwiches, we have Ivan Novikov of Volarm. Please, Ivan, go on.
Hi all. My name is Ivan. I'm from Volarm company, and working in security, information security area, in part of application security. But sometimes we need to relax and do something really cool, such as IoT hacking. And my short presentation about IoT device hacking and about practice, about vulnerabilities, and also about taxonomy of security. So, what I'm about, just research only household appliances such as multi-cooker teapots and other, not about IoT in area of car, vehicles and other. Just about only Wi-Fi only devices, not as Zigbee and others communication ways, not about Bluetooth device and other. And my talk only about end customer devices. For example, not about cloud security, not about other aspects of IoT security. We analyzed 5 devices from 3 different vendors. So before vulnerabilities, I want to talk about 2 different ways to produce this kind of devices, IoT devices. First is I call it Chinese way. Chinese guys take any device, for example, a multi-cooker, for example, teapot or other device, and find serial port, just a connection way between buttons and display, and then connect special Wi-Fi to serial main board module to serial port and profit, because at this stage Chinese guys got a really working device, any household device with Wi-Fi. And the second way is a Belkin way, I think US way, takes any existing device such as Wi-Fi router and make def something with black magic and do profit also. And therefore, when we deals with Chinese device, we deals with free RTOC operation system, and in US cases, we deals with Linux devices. And this is really great difference between to this kind of devices. So the first stage of device connection is the connect stage, when device came as access point and endpoint user want to connect a new IoT device to exists wireless network. At this stage, very important to various security things. It's encryption and credentials, which may be default, and also vendors must make sure that communication configuration interface disabled after initial setups. I think it's obviously cases, but also such devices have a magic way to connection. It looks like at first stage you enter your Wi-Fi SSID and password to mobile application, for example, for iPhone or for Android app, and then press enter and profit. That's all. At this stage, really hard to understand at first time what happens, but end point and a user device, IoT device, retrieve this SSID and password and connect to this wireless network. Inside this process, it looks 5 stages. First stage, your device, your iPhone or your Android, combine SSID and password to SP packet and try to find a network with this SSID. And of course, it's API call from all operation systems such as iOS or Android, and it's legitimate operation to find a wireless network with any SSID. But these guys use this ability to transmit SSID and password from any mobile device to IoT devices. And after that, IoT device catch this broadcast packet and decode SSID to SSID and password and store it and connect just in really magic way. And at this stage, of course, it's only one-time operation, but at this stage, any VAR driver, any wireless attacker can catch as an IoT device's broadcast packet and decode SSID and password. This connection way have a special name, but I can't remember it now. So, just some about backdoor stories. We found a nice backdoor in Chinese device, which consists of hard-coded IP address, using as really common line tools such as strings or the compilation process to retrieve IP address from firmware, and then try to understand for what these guys had coded IP address into firmware, and found that this address using as an NTP service, and this really nice idea because NTP service it's a legitimate protocol for all firewalls, and many devices use NTP protocol to synchronization times clocks. So basically, this backdoor provides to vendor ability to count all devices remotely, because all devices send the packets to a remote host. But also, if we try to research this firmware in details, we can find a memory corruption vulnerability in response passing function, and for that, vendor which can control this remote host in China can also make special crafted response to NTP client and exploit this end device as this vendor want. So just really nice backdoor, and really hard to understand what happens when you try to analyze only TCP DEMs, for example, because this operates only with valid NTP requests, and the NTP response with a payload can be so just about vulnerabilities. First vulnerability which I must to talk is a vulnerability in embedded web server in one Chinese device, and this vulnerability is really really easy to understand. When we connect to this device and want to get some administration functions such as administration panel, visit administration panel, this device asked us a password and login, and sent a valid response, but after that sent also second response with content of administration panel. Just a state bug in web server coded for free R2C operation system, and if you use a ordinary browser, you have no chance to find that. But if you use, for example, TCP-DEMP or Telnet, as shown in the slide, you can find this vulnerability and find a lot of fun. So, second vulnerability is vulnerability in one US vendor, it's Belkin vendor, and I still doesn't allow to publish details of this vulnerability because I received this email from Belkin Product Security today. But I must told this that just was a nice vulnerability, and this vulnerability I think must have 10 CVSS score. This is removed code execution vulnerability with root privileges, as you can see this slide as well at etc shadow from power supply. So it's nice. So, and another one vulnerability found it again in Chinese device, and this vulnerability nice because we can send a valid JSON packet, and this socket port only operates with only valid JSON packets, and it's not legitimate to send HTTP requests to this service, but the service path also HTTP requests, and for that we can try to exploit the service as a server-side, as a client-side request forgery, and put this link to, for example, a blog, for example, to other public resource, and when our target user visits this page, his TE port turned on. Just really nice because by design this network service doesn't allow any HTTP requests, only JSON-based protocol such as JSON RPC for raw sockets. So we try to produce a taxonomy of attacks and the taxonomy of vulnerabilities, IoT devices, and also try to classify various attackers by attack ways. First group, it's a website external from internet attackers which use in server side, client side request forgery or vulnerabilities like this. Second is Wi-Fi ghost. It's warp drivers and other guys. I thought a neighbor, it's your guys without your Wi-Fi password, and there's a difference between Wi-Fi ghost and neighbor, that Wi-Fi ghost have their valid password from your wireless network, home wireless network, of course. And the next group is a vendor which can put backdoors in firmware, and the last group is a retailer and delivery companies and others which can try to modify firmware after manufacturing before this endpoint and customer device came to customer. So I think the most important slide for my presentation is this slide, and also put it to the OWASP chapter as the IoT security checklist. And This is in one table presentation all takers models and also different checkpoints such as unprotected wireless access, authentication, encryption, authentication for firmware update, firmware integrity controls, backdoors and hidden exchange services, client-side vulnerabilities, server-side, and physical protection from damage with different metrics in the third column. We try to produce a way to compare levels of security of different IoT devices, different vendors, and different IoT devices. Of course, just not covered all aspects of IoT security, such as cloud security, such as mobile application, mobile client security, which used to communicate with IoT and other. But we try to cover end customer device security aspects and produce this checklist to make security audit process easier. So our stats: we analyzed 5 devices and hacked all of them, and found 3 backdoors. Found 3 backdoors in 5 devices, and also have no any ideas to deal a physical damage to devices, for example, explode this or do something like that. Because all analyzed end customer devices has a physical level protection, such as relay and other built-in physical protection mechanism. So I think that's all. If you have any question, I can answer. So thank you.
Thank you, Ivan. Now you had a special effect on the screen. Questions from the local visitors? So probably Aaron, you have a question.
I know everything about this. No, Ivan basically demonstrated everything I was talking about with regards to backdoors and ODMs and manufacturers. That was good.
I beg your pardon?
With Ivan's presentation describing the ODM issue in supply chain, I think he demonstrated it very well, that there is a big issue in the supply chain because there's so many backdoors by these companies, typically in China, who are developing the ODM stack.
Recently there was a presentation by a Hungarian member of a mobile chip or SOD producer. I mean, it's not a Hungarian producer, but the guy is Hungarian, so he was speaking at activity, and he said that there is a serious problem of within the supply chain, for example, of Android devices, because a lot of a number of vulnerabilities is in the low level of the system, and to mitigate this problem or to deal with this problem, producers of the devices have to rapidly include the patches provided by the SOD producer into their devices. I hope that this change was understandable. So and there are no management processes how these players of the supply chain cooperate with each other. So there are no institutionalized ways of cooperation between an Android device producer and an SOD producer. And the SOD producer is the root supplier of patches for certain drivers and all the components, low-level components of the system. Okay. Other questions from our online auditorium? No? Nothing. Jürgen, thank you very much, Ivan. That was what we wanted to hear from you. Jürgen, what do you think? Do we have a short break, or we can continue with your presentation now?
It would be fine from my side, but I think the audience in the Log Me In office would like to have a break, I think.
They already have had beer and sandwiches.
Oh!
So, Jürgen.
Do the point beer.
Jürgen, please, as represent, I should say that Jürgen and Aaron, they are representing OWASP among our speakers. So, and Jürgen came with an OWASP product.
Product.
I mean a project. So, go on, Jürgen. Thank you.
So, hi from my side. I'm Jürgen. I'd like to thank Aaron very much. He done a pretty good intro into the top 10, which I'm presenting. Let's dive into it. We have an agenda, the introduction, what misconceptions we are facing, considerations to be made about the OWASP top 10 Internet of Things top 10 project, and a short walkthrough, because we all know the risks, I think. Gartner says we will make 26 billion devices by 2020. It's a 30-fold increase, so quite a big market to explore. Yeah, it's with a 1.9 trillion economical impact, so there's quite big money to make, and big security issues we are facing. There's a misconception with IoT, where all people say it's all about the device. It's not just about the device, it's about the network and the clients. The problem we have is there are so many surfaces, just like Aaron said, and each of these need to be evaluated. So we have some things like the cloud, mobile application, we have network interfaces. We can go down to the network stack, for example, just as we heard at Aaron's presentation. Most of them aren't using encryption at all or authentication. There's poor physical security, and we have the good old USB ports, which like to be exploited. With the OWASP IoT Top 10 project, we like to review all the aspects of the Internet of Things and all the risks that will come with it. We divided it into 10 categories of risks, just like the original OWASP Top 10 for the web applications. It should cover the entire device. There is no specified device we're watching at. This is a generic approach. Yeah. The first risk we are facing is the insecure web interface. We have a threat agent who could be basically anyone who's having access to the web interface. The exploitability is quite easy, as you may know. The security weaknesses are pretty easy to detect. Mostly with automated tools, you can cover a pretty wide areas of problems. The technical impact could be hard, and the business impact is depending on the business mostly. It's a difference if somebody hacks your fridge at home, or if he's hacking a fridge for a big vendor, for example. How can we test this insecure web interface? We can test it with account enumeration. As you may see here, the account john@doe.com does not exist. Oh, so let's try the next one. We have weak default credentials like admin or admin password. All the bad passwords we are looking at. The credentials are exposed in network traffic. For example, if there are two devices in the network, they send their passwords in plain text. We have cross-site scripting, SQL injection, session with all the problems. We have problems with session management. We can fix sessions, for example, and log out people from their accounts. If you, for example, try to recover their mail for 3 times or something, their account get locked. How to make it secure? The OWASP IoT project gives a guideline for people who are manufacturer, who are developer, or even for consumer. The first thing I would do if I get a device like that, I change the default credentials, for example, and try to explore it. Would be the best thing. We have insufficient authentication, authorization, where we have an attack vector that is average. It's not too easy to exploit it, but possible. The detectability is easy, and it's quite common. We have a hard technical impact and business as usual. It depends on what you're doing with this IoT device. How to test it? It comes with a lack of password complexity. Basically, nobody is checking your password complexity on these devices. Prove me wrong. We have poorly protected credentials, lack of two-factor authentication if it's needed in this application. The password recovery procedure is mostly insecure. We have privilege escalation by just putting other roles, for example, in the get parameter. Oh, wait, no. And most of the devices have a lack of role-based access control. How to make it better? I need a good storage for my passwords. So I need to store my password secure as well as making strong passwords. Providing two-factor authentication for the customers. Insecure network services. There are problems with the network services, as Ivan just said, with JSON strings that could be exploited. The exploitability is average. It's uncommon, but we still face them. The detectability is quite a hard bit of work, and the technical impact could be data loss or denial of service, and could go over to other devices, and the business impact is depending on your business. How to test them? We see vulnerable services. They have for example, buffer overflows like in the 90s. We have open ports via UPnP, exploitable UDP services, denial of service via network device fuzzing. And I think the biggest problem is that all the devices, you usually don't have only one IoT device in your home, for example, or at your company. You have more of them, and they could become easily distributed denial of service if someone likes to get into them. How to secure them? Only expose the ports you're using. Basically reducing the attack surface. UPnP is a cool thing, but not in IoT devices. UPnP, yeah, no. UPnP only makes problems. We have a lack of TLS, of transport layer security, or transport encryption. What we are facing here is that if somebody tries to man-in-the-middle these devices, they all get stuck. We have the problem with unencrypted services via the internet and unencrypted services via the local network. We have poorly implemented SSL TLS, just like we had with Heartbleed, and most of the IoT devices doesn't even update their firmware. So they are still unpatched. Yeah, how to make it secure? I can refer you to the OWASP IoT Top 10 project, where you can read it for your need, where it's described for manufacturer, developer, and or consumers. We have big privacy concerns. For example, if someone followed the news with Samsung and their TVs, where the CEO said nobody should talk private stuff in front of their TV. Yeah, how to test it? Basically, you should watch the the network traffic to see if some data is transmitted over the net. They collect personal data like date of birth, home address, but they don't even need them. How do we make it secure? We can't make it secure as consumer, I think. It's a big gap that's missing from the side of the manufacturer or the developers, that they are producing it. Just like Aaron said, we need to make sure that there is a protection level for our consumers or our customers, and I think it's going into the right direction, but we have to still work on it. We have insecure cloud interfaces. Just like I said before, we have many of these IoT devices working together, and they are connected together, and the clouds as a central brain is one of the main parts that could be exploited and misused. So here we also have account enumeration, no account lockout, and the credentials could be exposed in network traffic, or they are transmitted poorly protected via the internet, via the net. How do we make it secure? We should use industry-proven protocols to communicate with the cloud. We should use a proper account lockout, for example. We could test it to SQL injection. We could test it against cross-site request forgery, and all those stuff we all know from the OWASP top 10. The same is with the mobile interface. We also have here the problems like no account enumeration, no lockout, and the traffic is exposed in plain text. How do we make it secure? At this point, I like to refer it to the OWASP top 10 project, because it's mainly made for this. With IoT devices, we are facing another problem. We don't have the possibility to configure security. Security should be, in my opinion, it should be a plug-in to a piece of software or to a piece of hardware. I like to choose my own security options and how hard they hit or something. Most of the devices don't have a granular permission model or password security options or monitoring and logging. Or if they have logging, where does the log go? If you're programming IoT devices, make sure that you're separating normal users from administrative users, as well as the developers. I'd like to once more refer to Aaron, where he said with the UART and the JTAG. Yeah. We have also the problem with insecure software and firmware, where the firmware could be updated via DNS hijacking or something else, where you can easily override the firmware. The firmware before it get updated, need to verify itself as valid. So we should use the in the computer world common hashes to verify, for example, the validity of the firmware. Or most of the devices doesn't even support self-updating. That's also a problem. How do we make it secure? I think it's a kind of process to implement security into these devices, because to make secure updates, you can't lay security over it. You must live security with the product updates. Last but not least, the poor physical security, where you can exploit, for example, the USB stack just by making big HIDs on the USB port, for example, or with malicious SD cards. I think if you have the device in physical, it is already hacked. So most of the problems we are facing here is this device could be hacked, but it shouldn't infect other devices, for example. How do we make it secure? That's a problem of the mostly of the hardware vendor we are using, or the developer is using, because it's a layer beneath. So mostly the manufacturer is in the liability to give a guarantee, for example, that his device is proven, for example, against certain attacks. Yeah, that's it, and I'm done with my talk.
Jürgen, thank you.
Wasn't that great, but
I think that it was great, and your topic is rather important.
It is important, yes.
Yours was the lecture, so it was difficult to consume. I ask our consumers at the location if they have questions, and I know that there is one.
Hello, Jürgen.
Hi.
Do you maintain a list about the products or node vendors regarding these top 10 topics? So some statistics about vendors or products. Do you have any kind of things?
Vendors that are known secure or known trustworthy, or?
Yeah, sure.
Okay. I don't maintain one, but I think there's going to be one. The OWASP IoT Top 10 is still young. There's still plenty of room to contribute. I don't even know right now. I don't know a list of trustworthy vendors. Sorry if I can't satisfy your question.
Are you satisfied, Bence? Bence was almost satisfied with your question. With his answer.
Okay.
Okay. Well, I was checking the live chat, and we still have no questions on the live chat. So please, guys and girls online, if you have some questions, then go on with the questions in the live chat. You have a live chat section at the bottom of the YouTube page, and even on my Android YouTube application, I see this feature of live chat, so you can ask your questions there. I'm talking about this because, as I said, we are experimenting with this technology, and I think that this Hangout thing with the YouTube, it works, and it was a stupid error we made at the beginning that led us to this 30 plus minutes delay, but actually it shouldn't happen. Okay, sorry, I didn't see the... Was it important, that message?
No.
Uh-huh. Well, let's introduce our audience. So, guys are still alive.
I thought they fell asleep.
Not yet. And Attila has an idea that he speaks now. He meant to be the first today, and he suffered the most because he couldn't deliver his speech at that prominent moment to be the first speaker. And the idea is that if we have a local speaker now, then it will energize our local audience. Attila, please. Am I online? Yes, because probably our online viewers misled with what's happening. Now we try to change some technical details of our setup, so don't go away. Stay with us. Yeah, and you can watch us live. We will cut it out from the YouTube archive. Actually, the things work like now our online viewers can see the event in real time and backwards for 4 hours. And when the event stops, then the YouTube video disappears. And then we will put back an edited version of the talks to the YouTube. Sorry, Attila, just we'll finish my thought that I think technical-wise we do a good event today because we have good sound for the presentation. So on the recorded presentation, you can enjoy that we did this part of things right. Attila.
Még egyszer üdvözlök mindenkit. Hello and welcome to LogMeIn Labs. We are happy to support the cause behind OWASP and participate in this talk about security of Internet of Things. So, are you afraid of flying? Yeah, I think so. I'm Attila Török, manager of security engineering at LogMeIn and security architect at Zively, our IoT security platform. And I did afraid of flying, but not anymore. I tell you why. Have you ever seen a cockpit from the inside? How can even anybody can start this thing? And it wasn't even that complicated back in October 30, 1935, when Boeing submitted the Model 299 for US Army aircraft evaluations. During the test flight, the aircraft made a normal taxi and a takeoff, and it was beginning a smooth climb. But then suddenly it stalled. It turned in one wing and fell and burst into flames upon impact and killing 2 of the 5 crew members. The test pilot, unfamiliar with the aircraft, had neglected to release the elevator lock prior to takeoff. Some newspapers had doubted it as too much plane for one man to fly. The pilot sat down and put their heads together. What was needed was some kind of way making sure that everything was done, that nothing was overlooked. Because the Model 299 wasn't too much airplane for one man to fly, it was simply too complex for any one man's memory. What was resulted is a pilot's checklist. Actually, 4 checklists have been developed, one for takeoff, one for in-flight, one before landing, and one after landing. These checklists for the pilot and co-pilot made sure that nothing was overlooked. And the idea of this pilot's checklist caught on. Other checklists were developed for other crew members, and checklists were developed for other aircraft in the Air Corps inventory. And eventually, it became a standard for commercial aviation. Knowing that pilots make sure that they don't forget anything makes me comfortable with flying. And who's not afraid of software vulnerabilities? I really do. Because number of airplane accidents decreased to 1,000th of what it was in 1945, while number of computer security threats shows the opposite. There has been more than 10,000-fold increase in the number of digital threats since 2003, just the last 12 years. And it's not likely to change anytime soon. So what you need to put your stuff online, you need a platform, a good platform. But define good. A good platform is reliable. Yeah, that's nice to have. A good platform is cheap. Yeah, maybe. A good platform is packed with full of features. Yeah, that's a must-have. And a good platform has good customer support. Anything else? Do you even consider whether it's secure or not? Hope so. You can ask, what's all the fuss about security? It's because everyday IoT devices packed with alarming number of vulnerabilities, as you can see in these previous presentations. Research reports, for example, by HP, testing various IoT devices commonly interconnected with our homes and businesses, revealed a plethora of vulnerabilities. 90% of devices collected personal information. 60% of devices using weak credentials. 70% of devices used unencrypted network services. And 80% of devices enabled an attacker to identify and steal valid user data. This report is showing 10 of the most popular devices in each of the most common IoT classes, such as smart TVs, webcams, home thermostats, remote power outlets, sprinkler controllers even, door locks, home alarms, and garage door openers, just to name a few. And most of these issues could be addressed by the IoT platform itself that your device relies on. So what can you do? How to tell it's safe and secure to fly your device from that platform? It's not straightforward. Security, more often than not, is an afterthought. For example, once airborne, the co-pilot of that Boeing 299 realized what was happening and he tried to reach the lock handle, but it was too late. This is the case for software security patches. It is often too late. Remember, how pilots can tell whether it's secure to take off? They use a checklist. If it works for airplanes, it might work for selecting an IoT platform. We at Logmin Zively created a checklist for ourselves containing more than 200 items. We go over with the checklist with our customers and make sure we don't slip over anything. But what type of questions should you ask to help you forecast potential threat? To find this out, let's skydive into the most fascinating area of security, my personal favorite, threat modeling. But what's a threat? Basically, it's a potential event that causes damage. It's as simple as that. It is something that may or may not happen, but has the potential to cause serious damage. Threat modeling is a security analysis to determine the most important security risks to a system. So neglecting to release the elevator lock prior to takeoff is a threat. And when these pilots, some 80 years ago, created their first checklist, they went over all these threats they can figure out. They did a threat modeling. Again, threat is a potential event that causes damage. Threat modeling is an analysis to determine threats. So the goal is to reduce the possibility of those events to an acceptable level by determining threats. You begin threat modeling by focusing 4 key questions. What do you want to model? That's a diagram. What can go wrong by identifying threats? What should you do about those things that can go wrong by mitigating them? And last, you ask that, did you do a decent job of analysis by validation? So the first step is to draw a whiteboard diagram of your component. The next step is identifying threats to the design. The third phase is mitigation. What should you do about those things that can go wrong? A possible result is a checklist for the pilots to make sure that nothing was forgotten. The last step of threat modeling process is validation. The objective of this step is to help ensure that threat models accurately reflect design and potential threats. In the steps, you check if you did a decent job of analysis. You ask this: is this threat model complete and accurate? So, did I do something with each unique threat I found? Did I write something with each threat? So again, threat modeling is a process to understand security threats to a system, determining risk for those threats, and establishing appropriate mitigations. This process is broken into 4 major steps: diagramming, threat enumeration, mitigation, and validation. If you do all these 4 steps, you are done. Or are you? Let me tell you another story about the Gimli glider. I read not too long ago in the IoT Security blog. A commercial airliner isn't supposed to run out of fuel at 41,000 feet, right? There are too many safeguards, redundant systems, too many regulations and checklists. So when that happened to Captain Bob Pearson on 1983, flying a twin-engine Boeing 767 with 61 passengers, he didn't have any standard they can rely on, any standard procedure that he can rely on. So when the cockpit warning sound emitted a sound that he or his first officer had never heard before, they were kind of shocked, because it meant that both engines had failed. Even if Pearson did manage to come for a landing, he didn't have any way to slow the airplane down. None of the procedures of the flight checklist covered this situation. Somehow, he had to fly the plane. The first officer suggested a former Royal Canadian Air Force base not too far away in a little city called Gimli. Pearson knew that the airplane was coming too high and too fast. Luckily, he was a skilled glider pilot. But, you know, airlines aren't designed to glide very well. They're too heavy, their wings are too short, and they cannot take advantage of thermal currents. So in desperation, he tried to maneuver called a slide slip. You know, it's by skidding the airplane forward in a way that ice skaters do when they want to stop. So pilots use this maneuvering with gliders, but it's never been tried with a commercial jet. So this slide slip maneuver has Pearson's only hope, and it worked. All passengers and crew members were safe. The plane was repaired at Gimli, and it returned to the Air Canada fleet for another 25 years. And it was affectionately called the Gimli glider. The story had a reasonably happy ending, but a mysterious beginning. How had the plane run out of fuel? To cut the long story short, safety features built into these instruments had caused the breakdown. Sophisticated airplane monitors fuel very carefully. This plane has two parallel systems that is just to be safe, so when one breaks down, the other functions as a backup. And investigation later found that a small drop of solder caused a partial connection between the two systems. And because of that partial connection, the computer couldn't decide which one is up, so it gave up and shut down the whole system. So thus the plane cannot tell that how many fuel it has when it was filling down the ground. So thus the plane took off with not enough fuel, and everything went well until it ran out of gas, and the both engines had stopped. Although in 1983, at the time of the Gimli glider, checklists exist for almost 50 years, there were no entries in the in-flight checklist for situations when the fuel ran out at 41,000 feet. So we cannot stop with the first version of our checklist, or let's call it threat model. We have to revisit and change it time to time. Approaching the destination of our flight, so to speak, let's circle back to our IoT platform checklist. What type of questions should you ask to help you forecast potential threat? you need to focus on these threat categories. Pretending to be something or someone else, also known as spoofing. Modifying something not supposed to be modified. It can be packets on the wire or in the air, bits in disk or bits in memory. Preventing something from providing service, including crashing it, making it unusually slow, or filling all its storage, aka denial of service. Exposing information to people who are not authorized to see it. What technical and administrative controls present in that platform to protect you from these threat categories? To cover all, you need to start asking questions. Questions starting with, does this platform protect against? For example, does this platform protect against creating fake devices? Does this platform protect against generating fake telemetry data? Does this platform protect against gaining device or end-user credentials? And 2,000 more. So let's see a few from the most important questions, such as, does this platform protect against unauthorized access? Let me give you an example of that. In 2013, a couple in Houston heard a stranger talking to their 2-year-old daughter through the baby monitor. Or in February this year, a 3-letter German car maker, starts with a B, issued a fix to their connected device software, connected drive software that allowed attackers to open car doors and remotely start car engines by their phones. Does this platform protect against unauthorized data modification? In a study spanning 2 years, found drug infusion pumps for delivering morphine drips, chemotherapy, and antibiotics, or even insulin, that can be remotely manipulated to change the dosage doled out to patients. Or there were Bluetooth-enabled implanted defibrillators that can be manipulated to deliver random shocks to the patient heart, or prevent medically needed shock from happening. Does this platform protect against eavesdropping data? A smart TV was hacked using a cheap antenna and relying on an insecurity in the hybrid broadcast broadband television standard. This standard is now features on millions of internet-connected TVs. And the so-called red button attack allows a hacker to intercept the sound, the picture, and accompanying data sent by the broadcaster, and then could take over apps on TV or even launch an attack from across the internet. And my other favorite, that has been mentioned before, the well-known manufacturer's privacy policy, which read, please be aware that if your spoken words include personal or other sensitive information, that information will be among the data captured and transmitted to a third party through your use of voice recognition. Thank you very much for spying on me. Does this platform protect against losing devices availability? There were X-ray devices in some cases that could be blue-screened and restart or wipe out the configuration settings, allowing an attacker to take critical equipment down during an emergency, or just crush all the testing equipment in the lab and reset the configuration back to defaults. So instead of hoping we don't forget an important threat, by using this method, this checklist or threat modeling method, we made sure we go over all potential threats. Pretending to be something, modifying something, prevent from providing service, and exposing information. So when you doing your threat modeling process to understand security threats to your system, focus on these threat categories and write down your findings into a checklist
to avoid unpleasant surprises. And before the takeoff of your next big thing, go over your checklist and have a safe flight. Thank you very much. Any questions? Online, maybe? Yeah, please.
How do you choose? Very often, engineers need to choose between two bad solutions.
How do you choose? Engineers need to choose between bad and worst solutions when they are implementing constrained devices. How you can use threat modeling to choose such a countermeasures?
Thank you for your question. So security is always about making decisions. So you don't have to fix all the threats that you found. There are multiple ways that you can deal with them. For example, you can just accept them. So if, for example, you are tracking that your pet, your kitty, is in the house or it's outside. If someone can eavesdrop that information, it's not a big deal, right? But if you are talking about healthcare information, that's the different end of the scale. So it's always about your risks and whether you want to accept them or not. Does this answer your questions? Any other question, please? One question that I've been asked last time I've prepared this speech is when are our methods, when this kind of checklist will be published. And actually, it will be as a kind of a white paper in the next few weeks. So I hope that you will find our research useful. Thank you very much.
Thank you, Attila, for the presentation. And it was enjoyable, very much. And I don't know, is it a new presentation? Was it made for this?
Hello.
Oh. Hello, Gregory.
Hello, Gregory. Hello. Can you hear me?
We just wanted to finish with Attila. We'll turn to you, okay? A moment, please.
So it's my turn.
Okay. 1 minute.
Can you show me the audience, please?
1 minute. So, Attila, prepared for this occasion, or it's your usual evangelization material?
It's more like my evangelization. So as I said in the beginning of my speech, threat modeling is my favorite thing, and I try to always evangelize this because it's not that difficult to do threat modeling, and it increases your security very much.
Thank you. Okay, Gregory, we return to you. Your turn.
Oh, yeah.
It's gone.
Okay.
We have this echo from you.
Yeah.
So probably you can mute the audio. I mean the output on your device.
Yeah. Well, I thought the audience was a bit sleepy, so won't you mind if I play some guitar just to wake the people up? What do you want me to play?
Not now, Gregory.
Not now. Okay, let's get straight to our main subject.
So let's go with the
So let's go with the
presentation.
presentation.
We are really in a, so we are late.
Just of course.
Gregory, we lost you. So Gregory seems to disappear now. If then we have to, I don't know. Sean?
Hello.
Are you ready to take on with your presentation?
Hello, everybody. Yeah, I can.
Hello, Sean.
Hello. How are you guys?
We are still live here.
Good.
And there are a few guys online too.
Yeah, we got some people. Hi, everybody.
Hi.
Yeah, I can go ahead with mine here. Let me pull it up. All right. Oh, hold on. I think.
Sorry, I got disconnected from some reason. So let me share my screen, and
so,
it will be okay.
We will try to continue with Gregory, if you don't mind. Okay. Sean, excuse us, and then Gregory, please continue.
Sounds good.
Does anyone can see my my screen? Okay.
It's not full screened now.
Should be better now.
It's a bit better, but again, there is something. But okay. Gregory, it's okay. It's okay. It was a problem with our screen. So what we have on the broadcast is, and what we are recording is perfect. So go on.
Okay. So my name is Gregory Estral. I'm also now a Taurus on Twitter, GitHub, and some forum as well. I work for a company called Lyra Network, which is a payment service provider. I have the role of development director. I have about 50 engineers working on a payment platform under my responsibility. But I'm also quite technical guy because I like to do some hardware hacking as well, and embedded development. So my talk tonight is about the security concern for the internet, as we already know it, but also it will be extended to some point to the IoT, because the problem with the IoT is that you will get more and more devices, low power devices with a limited amount of hardware and software capabilities connected to the internet, and above all, these devices will be close to our body, I mean wearables, so they will be able to disclose more and more information about ourselves. Okay. So the popular IoT application, as we already mentioned them in the previous talk, home automation, smart cities, wearable healthcare, and so. And these applications often use a set of protocols that have been either designed or reused for the IoT. I mean, for instance, protocols like XMPP or MQTT are protocols that take their root in 1999. And at the networking level, we have newer protocols like Sexlopan, RPL for routing, and DTLS for datagram TLS for bringing a TLS equivalent to datagram-based devices. Oh, sorry. So the focus of this talk will be home automation using MQTT. For those who may not be aware of what is MQTT, it's a very simple protocol which has an interesting model for all sensors-based automation, because it's a publisher-subscriber model. One of the requirements for MQTT is the use of a broker that is responsible for message passing. At its roots, MQTT was TCP-based protocol, and it has been somewhat extended to MQTT SN specification, SN standing for Sensor Network, and it allows the use of non-TCP protocol like ZigBee or serial links and kind of stuff. So let's build a simple home automation system. We get sensors. In MQTT, the MQTT resources looks much like HTTP or REST. It's more or less based on URLs with a different with a few chains, but let's consider those are URL for now. For instance, we could have sensors for temperature and humidity on the other side, commands to get to open your garage door or to tune up your radiator to the level you want for warming up or cooling down a room. And for all these sensors and commands, you have different requirements. For instance, in your house, the outside humidity could be shared with your neighbors that wouldn't want to add a sensor for it, or be broadcasted to weather forecast services that could collect your data to build better models of for weather forecast, for instance. Some data may be shared only to a set of people. For instance, if you're going on holidays, you may want that your neighbor were able to get the status of your garage door. If you're not supposed to be there, then your garage door is not supposed to be open. But disclosing the status of your garage door to everyone on the internet wouldn't be a good idea. Some commands need to be just protected. If you change the level of a radiator, well, it shouldn't have a very difficult, very painful consequences. However, some commands need to be secure. A garage door, if you want to replace your radio infrared based system with your smartphone, well, it's fine. But the downside of this is that you might open your garage door when you are 100 kilometers away, which surely isn't what you would want, or maybe just to allow someone that could have lost his keys, for example, for example, your son or daughter coming back from school, forgetting his keys and this kind of stuff. But for this purpose, we need a two-factor authentication at least, because you have to ensure more security, as misuse of this feature would leave your house open to anyone. Okay, so let's build our system. It's quite easy. MQTT is really easy to set up, and you imagine you're performing your local installation, everything works fine, and then you connect it to the internet or the IoT. For finding your home, you would like maybe a domain name, a DNS location, a Greg's house, for instance. And for security, you will choose a good old security standard, like not SSL anymore, of course, but TLS. And you will handle this for security, maybe with client certificates and only server certificates, this kind of stuff. But you would also make these certificates public and registered, so that people that would like to get your data, even if it's freely available, make sure that this data really comes from you. But okay, so I guess we're done. Not really. Let's talk about the two roots of our main concern currently with security, privacy, especially privacy. For these the latest years or 2 years, I mean, they have been very well spread in the news. DNS is a protocol that is weak. I think the first domain name takes its root in I think it was Xerox in 1995. So, no, 1985. Yes, that's 30 years from now, which is a lot in internet world. Then there have been abuse. I don't know if anyone here remember the Dicky move of VeriSign in 2003. They broke the whole internet with this abuse. And then there's a protocol weakness. It's the UDP protocol. There is no all the messages are sent in a plain text or plain data. It's really easy to spoof, to do some cache poisoning, to prevent some DNS server to deliver an answer. Well, I know you're aware of security, so these things are known to you. Sorry. With SSL and TLS, there have been implementation issues, especially for OpenSSL, Heartbleed, Poodle, and you surely have heard that a new set of vulnerabilities will be disclosed on Monday the 19th of March. So I think Monday won't be a good day for sysadmins over the world. Then still this case of abuse. There's the infamous self-signed certificate added by Lenovo to their laptops, just to put ads on Google page, and that breaks all DNS security. TLS security as it is intended to be used. And then more difficult to grasp issue related to cryptography. There have been the DBN random name generation issue that made private key issue generating Debian boxes very easy to crack. And then all of those are links. I encourage you to read the RSA key backdoor, which is a very interesting article. The principle is that you get your private key, for information on the private key, on the public key, making the key easy to crack. Well, DNS and SSL have had their implementation issues, are some protocol weakness, but that's not the main point. The main point is the way they are used. They are used, all our internet as we know it, use a hierarchical class model, which is which had its interest at the early beginning of the internet, but with all the recent events in the news, this is clearly not the way to go anymore. So let's talk about blockchains. Blockchain term blockchain comes from the Bitcoin paper. It's basically a set of transactions. It's a ledger, so you keep the balance of ownership of each Bitcoin of the system in a secure way, and the blockchain is not made available from download or from a particular website. It is shared by the network of a blockchain client. The question is, why does it work? Adding blocks to the chain means solving a computational hungry problem. It's not you cannot solve this mathematical problem with a brute force. It's much more like a lottery. So as for a lottery, you don't have more chance to find a solution to the problem than your neighbor. So why would people add blocks to the blockchain and verify transactions proceeded by others? That's because there is a reward. The reward is simply, in the case of cryptocurrencies, it's money. And everyone is a bit greedy. Everyone, I think, would like to have free money. And by using this incentive, this motivation that is shared by everyone running a Bitcoin client, then most people that are honest people sharing just this little defect called grid, we would outperform in terms of computational power. There's few people that would try to hijack the network. So it's not something that is easy to hear, but if you trust someone, you end up being disappointed, because the story of abuse on internet, on the backbone of internet, especially this last month, show that you cannot trust anyone anymore. For grid, it's very different because everyone shares the same grid, more or less. So some people are more greedy than others, but most people are greedy. We are all. Okay, why not? Okay, I can build about a blockchain. I know that it will be kept consistent by the network, but so who cares? Interestingly, major player of computing in general and in the IoT I've sensed that this idea of decentralized way of securing things is not a bad idea. So the set of technology used, Ethereum is basically a blockchain, TDH is a distributed hash table, and BitTorrent is used for file transfer. And funny thing is that 8 months ago, I had the same idea, and I created this simple protocol, proof of concept, sorry, Mosquito Twister. What is it? Twister is like a decentralized Twitter, sorry, that has been designed by a Colombian information technology researcher. A blockchain is used for storing handles, so you cannot have your account removed on this kind of stuff. There is no central authority that would do censorship of handles or what are published under this handle. User profiles are stored in a distributed hash table. The best known distributed hash table network was Academia, used by BitTorrent to make a fully decentralized trackers. The trackers were the weak point of BitTorrent at the beginning. And then all the data, so posts, are distributed like in BitTorrent swarms. A swarm is a set of users that share the same data of in BitTorrent case files. In a Twister case, only post. Direct messages are encrypted. Other messages are not, for obvious reasons. So, what does it have to do with MQTT? Well, you need to know and show that your house is your own house. If you trust on a third-party provider for DNS, with all concerns that's been addressed, one, you disclose too much security, too much information. You are disclosing, for instance, your IP address, which is unnecessary in this case. And why did I choose to use Twitter for this purpose? Just because the publish subscribe model fits exactly the Twitter model. People can subscribe, follow you on Twitter. They get the public information that you want to disclose, and then with a matter of followers and followers and following, you can ensure security. For instance, if you decide to trust someone, your neighbor, with that has proven its identity beforehand on a offline, let's say, on checking process. On checking, I mean, can be really shake hands with your neighbor and say, okay, let's see what I've done in my house. I'm trusting you to watch it while I'm on holiday, for instance. Okay. Now, as I've seen that question and answer section was a bit calm, I decided to add some ideas for you to think about security in general. We have talked many times about the difficulty to store private keys, but there are ways to avoid the storage of a whole key into a single device. One other topic could be adaptive security. Adaptive security is it's UX part of the security. You have to choose wisely what level of security you choose to one given situation. For €5 train ticket, NFC card will do. For larger amounts, you might want to add more to increase the security. Increasing security is not by increasing the security. I do not mean increase the security of a given device, but to combine many devices. And it is related to the former point. Use a quorum. So decide that for this operation, if I want to withdraw €100 from a cash machine, then I will maybe ask for 2 pieces of authentication. That would be stored across multiple objects, that in a secret sharing way. And to that point, cryptography. It's quite obviously stated that strong cryptography as a root of IT security. However, working with banks, with traditional electronic fund transfer system, as you may work with from time to time, especially people that are in the PCI stuff. You may wonder why when we are talking about 2048 bits keys for securing your Facebook post and your picture of your cat or whatever. Why do you accept to secure an object, a credit card, with a 4-digit PIN code and which use cryptography, which is a triple dash, but with only 2 keys, which represent a grand total of 112 bit key to secure your whole bank account. And you must admit that it works. It's not perfect, but it works. So, and then for those that are more familiar with the blockchain and cryptocurrencies, that's an open topic and no answer. It's just because I want to share my own thoughts and feelings about this part. First part would be the creation of a distributed blockchain storage, because the blockchain Bitcoin blockchain, sorry, is about gigabytes. And for other cryptocurrencies, it can end up to terabytes of data, which makes it inefficient and inappropriate for running devices of the IoT. And then back to my idea of trust and greed, especially greed. For such a blockchain system to work, you have to ensure that the incentive is powerful, is motivating. There are technical solutions to address the issue with DNS and HTTPS as well. That's the DNS chain project, but you may wonder what could be the incentive of such a project to make people willing to participate and free them from the power of people that and companies that we used to trust and that have betrayed us countless times. And I think with the IoT, it's like building a new internet, and we need to take this opportunity to make it to bring back internet to the people and not the corporation and the government. Thank you. If you have any question. Try to stop sharing. Okay.
So now you okay. So now I realize that you didn't hear what I was speaking, and so I told you, Gregory, that your presentation was one of the most interesting of the presentations today. Thank you. And I don't know if anyone have questions about revolutionizing the basics of the internet.
Well, I'd say it's not revolutionizing the basics, because there are still there, especially the DNS chain project. It works. Now there have been countless attempts of doing something web related and also more in the OWASP scope. I maybe for those interested in my slide that I'm presented to W3C workshop in beginning of 2014 about failed initiatives from Mozilla, Mozilla Persona, the diaspora distributed social network, the FIDO Alliance, the friend of the friend, the web of trust, this kind of thing that are maybe more easier to grasp when you are security experts in the web. When for the IoT it's a bit different because there are also hardware and security issues that I haven't mentioned there. But as I'm a hardware hacker at heart. I've been teaching myself electronics and FPGAs for some time, more than 10 years now, and I could show, but that would be for I think another event. Something you can do hardware-wise that are just scary.
Okay. Anyway, I believe that the new basics of the internet is the things we are talking about. Yes, I know that we are running out of time, but I wanted to stress that what you were talking about is the basics of the near future. Thank you, Gregory. Sean, please, if you're still there, live, then
I am. Yeah.
we switch to you. Thank you very much for your patience.
Oh, no problem. All right. Hello, everyone. So let me find my here. So I know it's getting late over there in Budapest. So I will keep this short. Can you see my screen okay? Oh.
Yes, we see you, and don't forget that it's not only the few people who is suffering down there in Budapest, but your presentation will stay recorded on the internet. So please.
Excellent. Okay, so I actually just put this together this morning. I just came back from vacation, and it was much required to get away from Boston after breaking the record for the most snow this year as of yesterday. So my apologies if this is short, but hopefully, since it's getting late over there, I will you'll enjoy it. So
please put your presentation into the full screen mode.
Oh, is it not in full screen?
Not yet.
Oh, it's full screen on my end. Let's see here. Try it again. Slide play from start.
It's probably Control Apple F or Shift Apple. I mean Shift Command F or Control Command F.
Yeah, it's in full screen on my end. So I'm not sure.
Or probably you share the other screen on the Hangouts. That's the guess.
Oh, that's a good guess. Here, let's try this again.
Credits to Mark.
Let's see here. Is that working now?
Very positive photo of you on Hangout. No, it's a different screen.
Let's see here. Let's see. Interesting. Let me try this. It only gives me 4 options. Well, why don't we just make it as big as possible then? There. How's this?
Uh-huh.
Does that work? Yeah, I don't know why it's not showing full screen, but this will work. Okay. So a little bit about myself. I am Sean Lorenz. I'm the Senior Product Marketing Manager for Xively, which is LogMeIn's IoT product. And we've been talking a lot lately about security and the Internet of Things. This year, it's been a big topic, and one aspect of it that I want to kind of talk about. You've heard a lot of different kind of interesting angles on security and the Internet of Things, but I want to focus mainly on the notion of identity in the IoT and what role that's going to play. So, as a former philosophy major from a former life, I studied a lot of Socrates, and one of his famous quotes, of course, is "Know thyself. The unexamined life is not worth living." So, one thing I guess you could take away from this is not only know thyself, but know thyself from a company's standpoint, and know who everyone is. And thyself gets a little more complicated once you think about all the different people and things that you have to include into that statement. So the real key here is securing all the things. The big problem with the Internet of Things, as far as if anyone has been watching a lot of the news, is out of CES, the Consumer Electronics Show, one of the biggest issues, almost everything was about security. People are, in general, pretty worried about this as a topic, and they should be. A lot of these kind of Kickstarter campaigns that have arisen, they don't really think about security up front. They just want to raise their goal for their cool new IoT product that they're trying to sell, and they try to do it as quickly as possible with probably off the shelf and open source packages that they can quickly get up and running, so that they can get this out the door fast. The only problem with that is security becomes an afterthought, as Attila said as well. And that's a big problem. There's a lot of issues that you've already heard about with this kind of approach, and so in order to really take this seriously, it has to be implemented in the design stage before you even start building something. And this is kind of counterintuitive to how a lot of things have been done to date. There are a lot of bigger companies now that are entering the Internet of Things, and they are thinking about this, but I don't think they're really aware either of what all these different aspects are yet. There's a lot to kind of tackle, especially for companies that have producing and manufacturing physical products for sometimes hundreds of years. Coal mining and different kind of manufacturing companies who've made light bulbs or any sort of other products, they weren't in the business of software and security. They were in the business of making physical things, physical products that were unconnected. Now that they're suddenly thrust into the world of the IoT, it's a new world for them. Understanding how to secure all this stuff is very foreign to them. So it requires a lot of thought up front with people that understand this from the get-go. And really, one of the biggest IoT hurdles, like I was mentioning, is this idea of identity and access management, or IAM. Really understanding all the complexity of what goes into an Internet of Things product. Like I said, the Kickstarter campaign, it might just say, okay, I'm going to connect your sprinkler up with an app. But that's just the beginning. It's not just possibly an app with some cloud service going down to the product itself, right? There's a lot more that has to get addressed. You have to understand all the different places and people and things and applications and business systems that are going to need access to all this data. So identity is no longer, like Socrates said, know thyself. Know thyself just got really complicated because all the thyself, it means there's a whole lot of people with identities in the entire chain of the IoT. So you have to think about not just the product being secure, both on the hardware and the board, on the wire, as well as in the cloud. But you also have to think about, are you building a Heroku application on top of it, an AWS application? Are you creating an end user app on an iPhone, as well as like a tablet app for a technician, or it might be a customer service rep, or it might be your CRM or ERP systems. As you can see, the number of people who need identity and access to something grows exponentially with the IoT, whereas in the past, this was much simpler. So, like I was saying, in the past, identity and access management was a very different kind of proposal. It's still, identity and access management is a fairly kind of new term to some people, and it's been a little bit easier to kind of understand as far as a lot of people thought IAM handled single sign-on and this kind of notion of understanding one app, one user, one kind of service, right? Whereas, that's not the truth anymore. Right now, there could be, multiple products for just one manufacturer. So you might have, GE makes a dishwasher, but they also might make a washing machine. A coffee pot. They may have 20 or even 50 different SKUs, and each of those products, might communicate to each other. But then, if we really want to take this from not just the Internet of Things, but the Internet of Things, you're going to want to communicate across all the different kinds of manufacturers. Your Lutron lights, your blinds, your floors. You get the idea. So, in order to really handle identity outside of the more traditional kind of web user interface and web kind of infrastructure setup, we have to find ways to handle the complexity of all these different users and identities that are trying to access the data coming off our connected products. So relationships, as Will Ferrell is showing here, are key to understanding the Internet of Things. And what I mean by that is, when you have a product, you have to understand how you build an object directory and trust and kind of authentication and all the different pieces that you have to put in for product life cycle management in the past also apply here, where you need to handle all the different relationships that identity has, as well as to the product and to the other people trying to access this. It was discussed in the last talk about MQTT. You can imagine your broker, you can have communication, secure messaging through MQTT, but in order to handle the complexity, there's many-to-many relationships involved of one device to possibly dozens of different entities, subscribe to a message. And then also published back down to not just to that device, but other devices as well, based on shared information. So really what we're talking about with identity, is knowing who has access to what and when. And that, I think, is at the core of a big piece of the security issue, is people really are a little scared to know who has access to what. And as long as you're securing that in a proper way by using an IoT platform that understands this and is able to kind of handle all these issues ahead of time, then it gets hairy. And if you're that Kickstarter company and suddenly you have users who want to make sure they're secure, they might be outgrowing themselves too quick. So as you can see, this is what makes IAM really difficult in the IoT. It's not just anymore about an app to a backend server. It's not just going a one user kind of system. It gets extremely robust, extremely complicated. There's a lot of different ways people have tried to handle this with graph nodes and different kinds of complexity of how do you even map this out. So when you're dealing with access and identity, there's a lot of handshakes that have to happen across the different users. And as long as you understand, you have users, you have applications and devices, and how each of these interact with each other before delivering and granting access to that information, then you're well ahead. You also have to deal with understanding the kinds of groups of information. So if, let's say, you're a building manager and you have access to certain rights, like turning on and off the lights, the HVAC system, you might grant someone who's only coming in for 2 hours to repair that HVAC system certain access at that given time. You may also give them different abilities in addition to just identity and access. So they may be able to access it, but they may only be able to access certain topics in the messaging, or they may be only able to access certain pieces of that information. So you can see there's a lot of really interesting ways you can limit this data for them. So where do you start? Really, I think this goes back to what I said at the start, which is think about it from the design stage. You have to take it seriously and not just keep it as an afterthought. This has to be something, if you really want to build a successful connected product, that if you get lucky and build the next Nest thermostat, you're going to have to handle the complexities that I'm talking about. I'm sure Google has had to deal with this as well. It's not a simple problem, and it requires a lot of thought. So when you're thinking through the security aspect of your product, it's extremely important to also think through your identity and how you're going to handle access and authentication for those users. So I kept it pretty short and sweet. That's it. Let me know if you have any questions. Thank you.
Thank you, Sean. So my voice is also online. Thank you, Sean. We have no questions from the online watchers of our show, and here is too few of us that we. Oh, now Bensa is the Oscar of the evening.
All right.
Do you have any practical solutions for managing these identity issues in practice?
Mm-hmm. Yeah. So this is obviously a big toss, easy softball toss, if you will, to what Xively is doing. You know, really what we've started to build is an easy way to handle those relationships. It's not the sexy, you know, connecting everything and making it all intelligent kind of aspect of the Internet of Things. It's a much more in the weeds kind of interesting way of handling the true issues that a real connected product is going to have to deal with something. So I would say that if you're looking to build an IoT product, I would make sure that you I think it's very difficult to build this kind of functionality by yourself, because as of now there is no kind of open source kind of management tool that you could do this easily. That's why Xively is doing this, and as of now I think we're the only ones really handling this outside of a customized a build. So right now, if you went to some company and said, we'd like to do this identity access management within our IoT product, they'd have to customize this for every person. And this is actually what Xively had to do in the past several years, was customize this for every single customer. And now we've realized that this is a core issue that every connected product is going to have. So we've kind of built it as a major part of the system.
Okay, Sean, thank you very much for accepting our invitation. I probably will try to substitute the video with your original presentation.
Okay, that sounds great.
Okay. Sean, thank you. And now it's very late, but we still probably better to finish it as we planned. So, Mark, it's your turn, because you will be recorded for the eternity. So this late hour doesn't matter.
Okay, can everybody hear me? Can Hangouts hear me? Great, I've got some feedback.
So again, we have these technical difficulties with the local broadcast.
Now, without feedback, more or less. Okay, let's try this. So, good evening, everyone.
I'm not sure if...
I'm the presenter.
Yes. Because...
it seems so.
Oh, probably it's only the problem of delay of the YouTube broadcast.
Yeah. Okay.
Okay.
So this is not going to be the traditional security presentation. Wait, one moment. I need the clicker. So I am also trying to make this a little bit interactive, so the people here can also get involved. So I have a little bit question answered. So my question to you is, how many of you have ever gotten angry with your computer? Yes. Okay. Everybody? Okay. How many of you felt ever lost regarding what the computer is doing right now? 1, 2, 3. Why is it working? What's happening? No? Okay.
It was the beginning of our show today.
Yeah. So, and my last question, who has ever gotten to the point with their computer that they got so angry that they shut it off or went out to rather grab a coffee or close the laptop because they were so angry with it? 1, 2. Okay, only my colleagues say that they have, but whatever. Okay, so my question is, in those situations when you don't really understand what's happening or you get angry with your computer or whatever, what are the typical ways to deal with this? What is the typical error handling that you would do? I'm thinking about really simple stuff like restart. What would you do? Just shout, yes.
Fire debugger.
Yeah, fire debugger. Debugger, yes. Task manager, antivirus, if you're afraid that you caught something. Yes. So the problem here is that all this situation that I've just described, how are you going to do this when your whole house is one information system? When your kitchen stops working? Are you going to get angry at your fridge? Or are you going to debug your fridge, debug your house, or get angry and go for a walk around the block? So the traditional means of dealing with problems in your computer system, they don't really work that way with an IoT system. So when we are planning for dealing with the traditional steps of security that we have to think of absolutely new ways. So the traditional steps are like prevention, detection, and response. And this is not just for security, but basically for all kinds of problems with computer systems. And if we say that the traditional means to this are not going to work, where are we going to get an inspiration for new methods? And just one idea, let's look how humans in their everyday life deal with these steps. How do they stay in control of their life, of their interactions, of their environment? So regarding prevention, what do people do? We avoid risky situations. If someone comes to us and he looks strange, we ignore them or we go away. So how do you do detection? If you feel that you're losing control, let's say you're in a foreign town sitting in a taxi and you're not sure what's happening, you start to be very careful. You observe very carefully what's happening. Sometimes you even open your phone and start tracking yourself on GPS, looking whether you're actually getting closer to your destination or something. And in the case that you see, okay, someone is fooling us or fooling me, then comes the response, which may be quite different. Someone will simply punch the driver, but you may also simply say, okay, let's stop here, and you leave, and you never go to that taxi company again. So these are the traditional ways how humans stay in control of their life. But there are still situations when you cannot be in control. Life is just too complex to be always in control of everything. So what you can do then is to start acting. So let's look at Alice when she got into Wonderland, where she certainly lost control. She started talking in riddles. I don't know who I am. I changed myself a couple of times. And if you think about it, that's also what you usually do. I suppose there are a few people here who are on Facebook, but there is a general pressure, so to say, that you have to be on Facebook. So also, people who are a little bit more anxious go into Facebook, but then they say, okay, I'm not going to actually reveal everything about myself. And that's also true for iCloud, for Google, whatever. So you're starting to act pseudonyms for services. But it's also what you do in your social interactions. You have a different persona in your family, in your company, at university, at a presentation. Not mostly this talking guy. So I'm also acting a persona here. So in those situations when we lose complete control, there's another behavior that humans rely on, and that's trust. Now, in computer science, there are quite a few different things that we call trust. So let's clarify here. So we can talk about trust, a human trusting a device. So do I trust my computer to enter my PIN number on it? So for example, Timur doesn't want to log in on my computer because it doesn't trust the hardware. But it's also true for IoT with sensor measurements. Do you trust that those measurements are correct? Sometimes you just simply look at the thermostat and say, that can't be true. So what you do in those situations is you try to check up on what the system is doing. The way to achieve trust between the human and device is mostly about user interfaces, mostly about getting more information about what's happening. But this also works the other way around. The computer trusts in the person who is using it. So, for example, Windows is checking, is this person capable of understanding what's going to happen when they install the software? So they have to authenticate them to be administrators, because if he's the administrator, he knows what he's doing with his own system. And it's also true for an ATM machine. It checks whether the person at the ATM machine is to be trusted to withdraw cash. That's also an interpretation of trust, but it's mostly realized via authentication. We can also talk about one device trusting another device. And this was this whole movement of trusted computing and checking system integrity via cryptographic hashes and so on. It didn't really work out, but there are also other places where one entity or one system trusts another system. Simply, let's say, the TLS protocol, where you see who the other party is via certificates and so on. And finally, a very interesting and new phenomena is when you have to trust a remote system. So the example from previously, do I trust Facebook, what they're going to do with my data? I have no direct interaction with Facebook. They're quite far away. So I have to make a remote assessment about how they are going to behave. But a simpler case is also when we look at peer-to-peer file sharing, that you have to assess whether the data that you're going to download, whether it's valid or not. So, as I said, humans tend to stay in control, and if they cannot, they have to rely on trust. So the more trust we have, the less we rely on control. And the interesting thing on this picture is that by default, we don't require complete control. So rather, in the case when we start distrusting someone, is that we require complete attention and complete control about what's happening. And the simple question is, why? And the simple answer to this is because all of us live in a system. There is a legislative system around us that's going to protect the banal everyday interactions where someone might try to fool us. So I'm going to trust that the bus driver who sits in the bus is really a bus driver, and if he's not, then probably he's going to get into a lot of trouble when someone finds out. And the same is true for virtual interactions. This whole new data protection law from the Commission will try to serve that point, that when you start using an online service, then you can be sure as a user that when you are sharing data, that data will be protected by the company, and if it's not, then legislation is going to penalize that company with quite severe costs. So the other point to look at is how can you achieve with your system that users are going to trust the system, so that users are going to give up some of the control, so they are going to allow that system into their homes. And one point which has been also mentioned by Sean is that the customers have to be assured what's going to happen with their data. And there are multiple ways, technologically speaking, how to provide this assurance. This can be simply by terms of service, which are not going to be read, so you can be quite sure they're going to be accepted. But that's one way to state to the customer what you're going to do with their data, and if they agree to this, then you are also obliged to hold your ground on what you have said. more advanced, but also quite difficult to implement method is to use pseudonyms, saying that you collect user data, but you're not going to pair that with some personally identifiable data. But then again, the question arises, if you have all the data about the customer, his behavior, you just don't have the name, whether then you actually revealed the persona or whether you didn't. And finally, you can realize completely anonymous systems. There are all kinds of methods already available from cryptography and other areas which will allow you to realize the complete security chain and data processing chain via only anonymous data. And another way to realize trust in your system is by involving the users, and you can involve them in multiple phases. You can involve them during the design, which is user-centered design, human-computer interaction. There are quite a lot of areas which deal with this, and what basically they want to achieve is that the system acts accordingly how the person waits that it's going to behave. So that the user interface, the interaction mechanisms are going to fit exactly the customer who is going to use that system, and is going to completely understand what's about to happen. But you can also talk about user involvement when you're talking about security, and this is one very important part, and this is going to be even more important with IoT, that security can be made understandable, and security doesn't have to be something where we consider the users to be the weakest link. The users have to be considered as an elemental part of the security, and they can be looked as such. And there's a lot of studies and a lot of research also proving this point, that customers and users are very capable of making decisions with appropriate weight. So my final statement, and the final statement for today's evening, is that don't make IoT into a rabbit hole. Don't make IoT into a leap of faith. Create a trust between your IoT system and the customer so that IoT really can provide a fruitful or beneficial solution, and it's not going to be the nightmare of all the security engineers as we are going to, or we are presenting it at the moment. That's it. Thank you very much. And if you have any questions from online or offline, if you want to argue with me, you can also do that, but probably then later on.
Oh, it's on. Okay. Probably I am muted.
No, it's the same account.
Sure?
Yeah.
Okay. My question is, I probably did not get your idea well, but the user involvement, is it to ensure the security?
User involvement can achieve the security that is appropriate for the user. So everyone makes security decisions every day. We don't leave our house door open. The reason why we have weak passwords for emails is because we don't understand that it's the same as whether when you are leaving your house door open. So security has been made very complicated in many cases, and because of that, there are many badly used systems. And that's also the cause for many of the security breaches. So when you start involving the user in the whole design process, and that also being the design of the security procedures, you will be able to achieve a security that is at the level where the user wants it to be, and not at the level where the user later on realizes that he's been stolen from.
Mm-hmm. Because think of social engineering. It builds exactly on the expectation of the user, what situations are comfortable for them to feel themselves safe, and so this kind of human psychology, sociology is exploited in that.
Yeah,
context.
but if you think of it, we are talking about social engineering a lot when we are talking about information security. But you have never heard of someone social engineering himself into your bedroom. Okay, you've got Casanova and so on. But simpler case is, so it has been shown that, for example, if you have an envelope where you have big black letters printed on it, confidential, then employees are going to put it into a drawer with a lock and close it and put that lock into their pocket and keep them to themselves. If you do the same with an email where at the bottom you say, please don't distribute this to outside the company, they're not going to handle it the same way. It's simply because we have a different representation of information security than we have for all the other stuff in our everyday life. And these two things have to come together, and then as I believe, and also how many of the surveys have shown, it would be possible to, for example, tackle also most of social engineering.
Mm-hmm. No, I absolutely agree with you that generally this is the way of improving security, but also it opens up a surface for another kind of attacks for Casanovas. Okay, Bence. Please. Just for our remaining online visitors, the number is around 8. So
two of these are you and me.
Yes. The number is 6. So anyway, the online visitors won this game. Bence is one of the organizers.
Okay, thanks. So you have presented for us trust model between humans and the computers and between computers. So in theory, between computers, the cryptography makes a complete or completely soluble trust model. Do you have any idea how can we achieve such completeness between humans and the computers?
Well, the first thing is that looking back into the past 10 years, we didn't solve the question from device to device. We don't have trusted computing. We don't have a working trust infrastructure for certificates. So although it's completely theoretical, we cannot solve it. So achieving the same level for a human device should be easy. And what's all about is really talking to the users and trying to understand them when you're doing your security solutions. So what hackers say that users are the weakest link is because hackers deal with the users. So if we as security engineers start to deal with the users, then eventually we can achieve the same level of security as between device and device.
Okay, thanks.
Okay, now we have a camera here. So thank you very much, Mark. It was a good decision to make a presentation today. And as I said, anyway, in 10 days it won't count that actually one innocent person remained with us. And this is why I encourage everyone or online community to make their meetups this way, because making offline meetups is the old way of doing meetups, and that way must die. So today we started something new, and I hope that in a year or two everyone will make such meetups as us. And actually we probably made one big mistake, and it's tolerable in this kind of experiment. I want to thank you, the organizers and the hosts, especially Attila, for the idea of IoT, which I was not favor of in the beginning, but it proved to be one of the best ideas for all topics. So let's make it short, cut, and goodbye.